is the third video in the first chapter of the Crystal Clear Electronics videos. In later programming exercises, we will often need to map the processes around us, everyday processes, into mathematical equations. We learned about these in primary school, but repetition is the mother of all learning.
That's right. But now let's look at a perhaps even more difficult problem, where we have to solve a system of equations with not one, but two unknown variables. A system of linear equations with two variables can be generally written down in this form. We'd like to solve the equation for x and y variables. Solving this kind of equations, we can get three different cases, which are going to be presented using examples. There are two simple methods for the solution. On the one hand, we can try to express one variable from one of the equations, then we can replace the expressed variable in the other equation. This gives us a single variable equation for the second variable, which can be solved. The other method, we can multiply an equation with a number, so in both of the equations, one of the variable's coefficients will be the same or opposite. By adding or subtracting the equations, we get an equation with one variable again. Let's take a look at some examples. In our first example, if we multiply the first equation by 4, we get minus 12x minus 8y equals 40, which, when added to the original form of the second equation, we get minus 10x equals 60. Its solution is x equals minus 6. If we substitute this into the second equation, we can also determine the value of y, which in this case is 4. Solve the same system of equations using the other method as well. Express the x variable from the second equation, then substitute into the first equation. This gives us an equation for y, which we can solve, substituting this back in to get the solutions. Obviously, we get the same pair of solutions. We can come to a contradiction if the two equations are not independent from each other. In this case, whichever method you use to solve the equations, you will get no solution, as shown here. Sorting the coefficients, we get that 0 equals 4. Thus, the system of equations has no solution. We get an infinite number of solutions if the two equations differ only by a constant factor, in which case the two equations are equivalent, so we actually have one equation for two unknowns. In this case, we get the equation minus 3x plus 2y equals 10 from the two equations, which means that infinite pairs of numbers satisfy the original two equations.
Thank you for the quick explanations. I feel that we are making very good progress. I can't wait for the next video.
Yes, the tempo is nice. I would encourage viewers to go back to the mathematics basics several times, and if something wasn't clear, maybe the repetition will help. See ya!